Thank you everyone for joining us on episode 8 of the Computomics podcast. We will continue our discussion of biotechnology and the ways that it's serving the world. And one topic that's been coming up lately for us and something that we've been really excited to talk about is the incorporation of drones or UAVs into the agricultural landscape. And today we thought it would be interesting to have a conversation around these topics with Larisa Golovko. She's the owner of Landviser, and she has been interested in this topic for already a decade and more. So, Larisa, welcome.
Thank you, Anna. I'm glad to be here with you.
Maybe you can give us a short introduction of how you got into this field, what drones and UAVs and UASs mean to you, and just sort of welcome us to the topic.
Well, I'm originally from Russia, and I'm not grown up on the farm, but I come from the family of soil scientists and geologists. And my dad was working and was professor at Moscow State University in soil physics. Soil physics is basically the all kind of methods measuring soil physical property, be it water content, clay content, like texture, structure, how water moves in soil, even like how fertilizer moves in soil. So I've been, exposed to this through my childhood. I worked at Rutgers University. While doing that, I started Landviser, invented their short handheld electrical conductivity meter called Landmapper, and I've been using applying sensors to agriculture applications, like measuring how fertilizers impact soil. Like you can map the soils with it, you can do a lot of stuff, but basically what I'm trying to focus GIS and sensors, be it electrical conductivity, precision agriculture. It started about maybe 20 years ago and really pick up lately, maybe 5 years, with explosion of this unmanned UAVs and short drones. But the drone is just a vehicle. You can use a Landmapper, you use a sensor, and you can walk, stick it in the soil, and take a measurement. You can go with a just normal camera and take a pictures, and it's a sensor. But how you go, and then you put the camera on the drone. Then this is like you still collecting pictures. What do you do with this information? How do you analyze it? This is actually
right. That's the interesting part, that you have to make sure that you are using the technology in a way that is resourceful and useful and is actually getting you to the results that you want. So just sending a drone and capturing millions of pictures without a way to make that useful isn't really going to serve anybody except for the companies storing those pictures. So,
get out of hand pretty quickly, because also, I don't know if the audience is interested to know that you can just take what they call visual spectrum. Basically every picture you take is capturing three what they call bands: the red, green, and blue. And that's like how we see the pictures. But in agriculture and in other application, it's can be very useful, not only like visual, but other spectrum, like which human eyes cannot see, called near infrared. And then using like 4 bands, so adding like a near infrared band, you can deduct a lot of information about like crop health, crop stress, like water stress, very easily. Or like, is the crop mature, is it ready to harvest? Sometimes in different crops, like I was working long, like 15 years with a rice breeding company, and like particularly you can deduct when like grain is ready to harvest. from those, if you just add one near infrared band. But I
Mhm.
also worked with some sensors that companies on the market, like which not really develop drones, but they develop those sensors. And there's like
Mhm.
6 band system there. There's some companies utilizing like thermal. So it's a different range of.
Yeah, it's amazing because the amount of data, like you said, can really get out of hand quickly. And initially, what I see is that people think, oh, great, the more data, the better, right? So if I capture, maybe I don't know what to do with it, but if I just capture it, then I'll know what to do with it at some point. And I think what's really disappointing is when you realize that for a lot of these clients or interactions, the data actually just ends up sitting around somewhere without really being useful, right? So what do you think are the key metrics to really make sure that this data captured by these devices with whatever sensors a company decides to use, that it's actually useful for somebody? What have you seen with your experience can make this data actually produce results?
Well, the data in itself, like I've seen a lot that, yes, like you said, the collecting data is a case of point, and people say, well, we are data driven, we are, but unless you have a algorithm, I mean, I think the keyword here would be the algorithm, or
Right.
something like an easy system for the customer, for client, for researcher to like integrated data. Like you collected like some sensor information, some say drone imagery. How do you integrate it with soil? How you integrate it with weather was happening?
Mhm.
How you integrate it with actual crop records, which normally all the agriculture collect, like when the crop like emerge, when the crop start flowering, when
Mhm.
the harvest. This, if you can even just integrate without even algorithm, you can sort of layer information on top of
Mhm.
each other, and
Mhm.
that's what actually what GIS is called, geographical information system, right? Even before drones were there, everything. GIS started as a, so you can put those layers digitally on the computer. In
Yeah.
1960s, Environmental Science Research Institute, ESRI short of, in California, they made, from the paper maps, they make the jump and they build a software which people can lay information around. And
Mhm.
since
Mhm.
then, I mean, there's like what, 50 years ago, and they pretty much became the de facto, um, they invented the word GIS, right? And the
Mhm.
whole technology. So now with the, I would say again, explosion of the easy collecting data,
Yes.
then we have open source, you know GIS platforms. We have open source like languages like Python and others, which people, and some modules algorithm already there. But in agriculture, in the breeding, and I think this is like, we are now the company who would focus on connecting the dots, so to speak, right? Connecting
Right.
the data and building and deriving those algorithms, or maybe already derived. I know Computomics did like quite a few strides on this direction.
Right.
So that would be, I guess, that's where you get the value out of information.
Yeah, that's really what I see as well in my interactions is that sometimes people ask us, well, what really sets you apart? And it's the answer really is the algorithms. It's the way that we combine and make sense of information, and it's a little bit hard to demonstrate for people, right? Because we don't know their information, and it's hard to really convince somebody when you demonstrate making sense of somebody else's information, but it really is the way that you take a lot of data and you connect it and make insights from those connections. Because of course a plant isn't you can't measure a plant just with images, right? You need to know, like you mentioned, the environment, its genetics. You need to know a lot of things about it to really understand and predict what's going to happen next. And again, just understanding without a prediction for the future is also useless, right? So it doesn't help you if you understand something if you can't do anything with that understanding. So I definitely agree with you that it's the algorithms, it's the way that data is put together, that's really going to make a difference. And the other thing that I wanted to say is that I think the collection frequency of data is often extremely bloated in these situations. We've done quite a number of analyses where we've seen that people can collect 10 times less data and produce the same results, right? Depending on what they really need the data for. For example, weather data, they don't need hourly forecasts.
Yeah, I have experience with exactly that. We had like collecting, subscribed for the service, which, weather data was coming every 15 minutes.
Yes.
Then we realized that maybe hourly data, and we actually build a model using hourly data, but in the long run, we ended up actually using daily minimum and maximum temperature, because this was unified data source and across the globe, and it was really available, and it actually gave
better results.
Not better, it's more applicable, more practical, more
more
useful. And sometimes, yes, people get excited, we can have 6 bands, right? I collected last year 1.5 terabytes of this imagery, only maybe from 20 fields and a few flights. That where do we store? We could store it, but in the efficient way to actually people act on those data, we end up not really utilizing it. It's safe, it's there, it was good insight on many projects, but the system was not there
to really pull the information
actually make it actionable. It's a cool technology, but regulations are not allowing to operate as it intended right now.
Yeah, it's very interesting, the limitations, the same that when we talk about, for example, cannabis breeding, the concept of what we can do for cannabis and hemp breeders is so different than what we can actually do because of the regulation, right? So in the same sense that you think, oh, let's just let all these things fly around, but really there's a lot more depth there than what you can think about. Well, as a final question, maybe I can ask you what you imagine to be the future for Landviser and also for drones in agriculture in general, and how would somebody contact you, and why, who would you want to contact you for partnerships or?
Well, I guess future is, like I said, future is an integration of the systems and an algorithm. We are as a geophysical equipment company with a a lot of experience, particularly in agriculture and near surface geophysics. So you can go to landviser.com and see all the contact information, call, email. We have office in Houston. We have a connection in a company in Europe and in Prague and in Russia. So I'm just open for any partnership, how we can merge different system, different information together. And
Great. Well, thanks so much for joining me, and I hope we continue working together.
Sure, yeah.
So thank you everyone for listening. I hope you enjoyed that episode. I hope you learned something about the importance of using the right amount of data, and data that will serve a purpose, data that will help you along the way instead of just collecting mass amounts of data. That's definitely something that we help our clients with, and would be happy to work with you and your GIS data to make it useful and beneficial for your agriculture needs. If you would like to contact us, please go to our website, computomics.com. Feel free to reach out to Landviser and Larisa, and we hope to hear from you soon.